Hi, everybody. This is Dr. Grillo, and this is the second lab. And so the objectives for this lab is we're going to create a secure remote access to the switch using Secure Shell or SSH by default. Telnet is another remote method. Uh, and the problem with Telnet for remote access is everything you type is in clear text. So when you try to log into a switch remotely with Telnet, you key in a password in your entire session. The commands that you perform remotely are recorded in clear text. And so we're going to use Secure Shell, disable Telnet, which will ensure that our method of remote access is encrypted. And then we're going to create virtual networks or VLANs. And VLANs are logical networks, not physical, because we only have one physical network here in this diagram. We can create logical networks on switch ports. And these VLANs operate at layer 2, not layer 3, because it takes a layer 3 device for inter VLAN connectivity. And how do we do that? We do that by creating sub-interfaces on the router for each VLAN. We'll create trunking for the VLANs. Trunking is defined as carrying traffic from more than one switch port. And we're going to create sub-interfaces, again, on the physical gateway. Finally, we're going to create a serial connection, which represents remote wide area network access between two routers. We'll call them Building A and Building B for our organization called XYZ. And then we'll advertise routes between these two routers using EIGRP dynamic routing protocol. So let's just go ahead and get started, and I'll talk my way through as we go along. The first thing we're going to do is we're going to go to the switch, and we're going to configure ports 5 and assign it to VLAN 5 for PC. That will belong in a subnet 10.10.5.0. The third octet here is going to represent VLAN 5. Likewise, on port 10, we'll create a VLAN 10 on port 10, connect to PC. That PC will belong to VLAN 10. And again, we're using the third octet to represent the VLAN. We'll also create a management VLAN. We'll assign an IP address to a switch. Now, why would you assign an IP address to a switch if it's only a layer 2 device? Well, you'll need an IP address that's assigned to the entire switch if we wanted to remotely access it. So in other words, we don't have to be physically at that switch in order to be able to configure it or make changes. We could do it from one of these PCs here if we wanted to. And so the PC will be in a management VLAN called VLAN 100. And notice we'll use the third octet for VLAN 100. We'll create 3 sub-interfaces on the router, right? So this is one physical network, but how do you create 3 gateways on one physical gateway? Well, you do it by creating sub-interfaces. Look at them as subparagraphs, right? You have a main paragraph, which is the main port gigabit 0/0, right? And from that main paragraph, we'll create 3 subparagraphs or 3 sub-interfaces, one for VLAN 5, one for VLAN 10, and one for VLAN 100. This port right here, the connection between the router and the switch, we'll have to enable it for trunking. And we do that on the switch port gigabit 01. So what is trunking? In a nutshell, trunking means this connection is going to carry traffic for more than one VLAN. So you could have simultaneous traffic going inbound or outbound from VLAN 10 or VLAN 5 or VLAN 100. And so that's what we'll do with this port, configure it for trunking. So let's just go ahead and get started. We'll go ahead and click on the switch. And by default, all ports come up on a switch. We're going to hit enter. And I'm going to do some shortcuts this time instead of just spelling out the commands, right? So we're going to type EN for enable. Takes us to privileged exec mode. Then config T. Notice I'm abbreviating commands. takes us to global configuration mode. We'll create a host name. We'll call it XYZ. We'll create the line console password. And the password will specify as Cisco. And we want to be prompted for a login, so we type login. Okay, and then we'll type in the enable secret password of Cisco as well. Okay, so first thing we'll do is we'll go to port 5. We'll go INT space F0/5, key in the command switch port mode access, and then we'll key in the command switch port mode switch port access. We'll assign port 5 to VLAN 5. Okay, you'll get the prompt saying that the VLAN doesn't exist. VLAN 5 has been created. Likewise, we'll do the same for port 10. Now, there's a command history recall. If we hit our up arrow 3 times, right, and we're going to configure port 10, we're going to repeat the process. We just changed the 5 to a 10. Hit enter. Hit the up arrow 3 times for switch port mode access, and then hit the up arrow 3 times and change VLAN 5 to VLAN 10. Okay, so ports 5 and 10 have been configured for VLAN 5 and VLAN 10 respectively. Now remember last lab we did port security. So we'll enable port security on VLANs 5 and 10, but there's a way to do it when you use the interface range command. So you can do ports 5 and 10 simultaneously. So if I do this command, interface range, now don't hit the enter key yet, just watch what I'm doing. If I go F5 space dash F10, dash would configure ports 5, 6, 7, 8, 9, 10 simultaneously, right? We don't want to configure ports 6, 7, 8, or 9, just 5 and 10. So to do that, after the 5, we hit the comma, hit the space bar, and then we type F0/10. Hit enter. Now notice how your prompt changes. You'll see the range here. Letting you know that any commands you do apply to ports 5 and 10 as well. So if you recall from the last lab, you type the command switch port dash security, hit enter, hit the up arrow, hit the space bar, type MAC dash address, sticky, hit enter, hit the up arrow, erase MAC address sticky, and type max1, and then hit the up arrow and specify the violation. Delete max1 and type violation, shut down. Okay, that configures port 5 and 10 for port security. Okay. Next step we're going to do is assign a switch an IP address and put the switch in its own VLAN 100 for management purposes. Okay, so from here, we're going to go ahead and type the command VLAN 100. We're going to create it, and we're going to give it a name. And we're going to call it management-VLAN and hit enter. Okay, next step is to type the command. We got to go back to global config mode, and we're going to create the virtual interface for VLAN 100. Interface VLAN 100. Interface has gone up, and the next step is to assign an IP address to the switch. We're going to key in the command IP space ADD space 10.10.100.2. .1 will be the gateway that we haven't configured yet on the subinterface on the router, and specify the network mask of 255.255.255.0. Okay, I'm going to type exit. Now, if the switch is going to have an IP address, you got to treat it as almost like a PC on a local area network. It needs to know the address of its default gateway, right? So on the switch, how you do that is you type the command IP space default dash gateway, hit the space bar, and this is going to be the gateway address of the router on the sub interface. We haven't done it yet, but this will be the IP address 10.10.100.1. Okay. Next thing we're going to do is we're going to set the switch up for using SSH for remote access. Okay. And how we do that is the first thing we got to do is specify a domain name. Okay. We're going to type IP domain dash name xyz.com. Okay. Name of our fictitious company. And we're going to go ahead and hit enter. Next step we're going to do is generate a crypto key. We're going to type crypto key generate RSA and hit enter. And if you get this prompt saying you want to replace the keys, say yes. If not, this is what you're going to be prompted with, how many bits in the modulus. Okay, so the modern day switches use the version 2 of SSH, which requires at least, I believe it's 768 bits. But we're just going to double this number to 1024 and hit enter. And then you see the crypto key is actually generated. Okay, our next step is to specify that we are only going to allow, well, first thing we need to do is generate a username and password. So if we're going to access the switch remotely, we have to have a username and password to log onto the switch remotely. And I'm going to make those username and passwords different than the Cisco, so you get to see how it works. Okay, I'm going to type username. You could type any username. You could type your first name. I'll type John, hit the space bar, and the password will be ABC. Okay, and from here, I'll hit enter. Okay, next thing we need to do is specify that the only method of remote access will be SSH, because by default, Telnet is enabled as well. And I went over the security issues with Telnet. So we're going to go to line VTY space 0 space 4, hit enter. And from here, we are going to key in the command transport space input. And after input, hit the question mark. And by default, all protocols are enabled. Now, if I specifically leave this alone, SSH is going to work. Telnet could work as well, right? And so if I specify a protocol, that will disable Telnet. So after input, I'm going to type SSH. Okay, and then I'm going to type in login local and hit enter. Okay, now this completes the switch configuration. So I'm going to type end. And from here, I'm going to save it to our non-volatile random access memory. So if you recall from the previous slide, what copy run start means is copy what's running in memory. Because right now this config that we typed is just running in memory. If this switch were to be power cycled, we'd lose everything we just typed, right? Copy run. The start means copy to the startup configuration file maintained in NVRAM, or non-volatile random access memory. NVRAM is analogous to a hard drive on your PC or laptop. So think of it as a Word document that you have to save, right? And so we're going to hit enter once and hit enter twice. And that completes the switch configuration file, okay? Now, What we're going to do next is configure the IP addresses for the PC on VLAN 5 and VLAN 10. They're going to be on different subnets, okay? And we're going to demonstrate how VLANs operate at layer 2. Because even though we've configured the switch correctly, and when we do the IP address correctly on VLAN 5 and the PC on VLAN 10, the PC on VLAN 5 will not be able to successfully ping the PC on VLAN 10, right? Because there's no sub-interface yet configured on the switch, okay? The way the traffic flow is going to work when the PC on VLAN 5 wants to reach the switch or the PC on VLAN 10, it doesn't go from here to here. The traffic flow goes from here up to its default gateway on the sub-interface, exits out on the sub-interface gateway for VLAN 10, down here, and back to VLAN 10. So that's the traffic flow. Likewise, if the PC on VLAN 5 wants to remotely access the switch, traffic flow doesn't go from just here to here only. It goes from here up to its gateway and back out on the gateway for the switch, right? So you got to remember, these devices are on 3 separate VLANs, are on separate networks, and they need 3 separate gateways in order for true inter-VLAN connectivity to work. Now, there's one last thing I forgot to do on the switch, right? You see this gigabit port right here, gigabit 01? This is a trunk port. So this trunk port, a trunk port is defined as a link that can carry traffic from more than one VLAN. And so we have to configure the gigabit 01 port for trunking. And to do that, we type the command config P, go to that port, interface G 0/1, and type the command switch port mode trunk. That's all you need to do on that port. Okay, you can give ports descriptions. Remember we did it on a router in the last lab. Well, on a switch, you can give them descriptions too. They're optional. You can call it connection to building a router, whatever you want to call it, trunk port, or just trunk, and hit enter. Okay, now we can type end, hit enter twice, and do your copy run start again, and save the switch configuration file. Okay, next step is to configure the IP address on VLAN 5 for the PC. Click on the PC, go to IP configuration window. We're going to give the PC an address of 10.10. Again, 5 in the third octet represents the VLAN it belongs to, and then followed by the IP address of 2. Right? All the .1 addresses, the first available IP addresses in the subnet, we're going to assign to a gateway. Now, the third octet doesn't necessarily have to be a 5 in order for it to work, but it just makes sense, right? When you're looking at IP addresses on your network, to see a 10.10.5. something, you would know it's coming from VLAN 5. Tab over to subnet mask, and we're going to change that to 255.255.255.0. And the gateway, even though we haven't configured a sub-interface yet, will be 10.10.5.1. Hit the tab key, and you can close the VLAN 5 window. And likewise, we'll configure the PC on VLAN 10. Click the IP configuration window. We're going to key in the IP of 10.10.10. Again, the third octet represents the VLAN. .2. Tab, and subnet mask will be 255.255.255.0. And the gateway address will be the sub-interface on the router will be 10.10.10.1, and hit the tab key. Okay, now if we go to I'll show you how the ping will be unsuccessful, right? Because then you know that VLANs are only layer 2, because it takes a layer 3 router with sub-interfaces for inter-VLAN connectivity. If I click on the PC on VLAN 5 and go to the command prompt, okay, and I try to ping the PC on VLAN 10, I type ping 10.10.10.2, okay, that ping's going to be not successful, right? You're going to get 4 timeouts. I'll wait for the first one to come up. And you could do a Control C to cancel it, right? The rest of the packets aren't going to go through. Okay, next step is to configure the sub interfaces on the router. Okay, we're going to click on the router. And for system configuration dialog, we're going to type no and press enter again. Okay, now you can configure the line console password, the host name, and the enable secret password on your own. Okay, it's the same method we did it on the switch and the same method that we did it in the last lab. Okay, so we're going to type EN for enable, abbreviated shortcuts, and then I'm going to type CONFI space T. See if CONFT works. I believe that works too. Okay, so that's a further abbreviation. Now we're going to go to that physical interface right here, right? And how you configure sub interfaces is you first go to the physical interface, D00, hit enter, and you turn it on with the no shutdown command. And that's all you do on the physical interfaces. You just turn it on. Don't configure IP addresses on the physical interface. You create sub interfaces. So we'll create our sub interfaces. We'll type int G0/0.5. The .5 represents VLAN 5. Now, it doesn't have to be a .5. It could be any number, but again, it makes sense for all your 5s and your IP addresses and your interface, sub-interfaces to align with VLAN 5. Makes everything easier, especially on a large network. Oops. Click back on that router, and we're going to hit enter. Hit enter again. Now notice the interface automatically comes up, so we don't have to turn it on. But notice how your prompt changes to config-sub-if. Okay. First thing we're going to do is set the encapsulation. So this is a trunk port, right? Because if you recall this link here, it's going to carry traffic from more than one port. The router has to specify the switch trunking encapsulation. And there's 2 types of encapsulation. One of them is ISL, which is Cisco proprietary. It's not the most commonly one used. The more commonly used trunking encapsulation is .1Q. So we're going to type ISL would work, but we're going to specify .1Q. So we're going to type encapsulation. We're going to abbreviate it by ENCAP, hit the space bar, type .1Q. No spaces there. Hit the space bar and type the VLAN number. This is what specifies the VLAN for the sub interface. Okay. And now we're going to hit enter. And now we're going to give the sub interface a default gateway IP address. So it's going to be IP space ADD 10.10.5.1. Remember, the PC was .2 space 255.255.255.0 and hit enter. And that's your first sub interface. Now I'm going to show you some shortcuts. Again, you're going to hit the up arrow 3 times because now you need to configure the sub interface for VLAN 10. We're going to change the 0.5 to 0.10. Hit enter. Hit enter again. Hit the up arrow 3 times. Change encap .1Q5. Change the 5 to a 10. Hit enter. And then hit the up arrow 3 times. And you can actually move your cursor over right before the 5. Hit the backspace key and change that to a 10 and hit enter. Okay. Now we need to do one more sub interface for the management VLAN. So you're going to hit and that's VLAN 100. You're going to hit the up arrow 3 times. And we're going to create our third sub interface. This will be .100. So you just add another 0. Hit enter. Hit the up arrow 3 times. Really saves time, huh? And cap .1Q. Okay, change that to 100. and hit enter, and hit the up arrow 3 times. Position your cursor right before the 10, add the extra 0, and hit enter. Okay, now all your sub interfaces are up. And so what we're going to do is type end, hit enter twice. You can verify it with the show run command. So if you type sh space run, it shows you what's in your running configuration, what you've done so far. Okay, notice we haven't created a host name yet. And you can do the same thing on a switch, type show run. And what we want to do is look at our sub interfaces. This is what we did right here. Okay, so all we did on the physical interface is we turned it on. We know it's on because if it was off, it would say shut down. And we look at our sub interface for VLAN 5.1Q5. Everything lines up. You got the 5 here, you got the 5 here, you got the 5 here, you got a correct network mask, .1 for the gateway, and VLAN 10, VLAN 10, VLAN 10, .1 for the gateway, correct subnet mask, and then VLAN 100, VLAN 100, VLAN 100, and you got the correct network mask. So again, you want everything to align because again, on a large network, on a large configuration file, it just makes it easier to see, right? What port is doing what. Like I can quickly look at this config and I can say, oh yeah, gigabit Ethernet 0/0.5 VLAN 5, right? Without even looking at the rest of it, right? I would know that this would belong to VLAN 5. So you want your naming conventions and your numbering conventions to be consistent throughout. Now to quit this, just hit the letter Q on your keyboard, and we're going to save this config, and we're going to type copy, space, run, space, start, and hit enter twice. Okay, now we're going to test it, right? So the PC VLAN 5 should now be able to reach the PC on VLAN 10 because the packet is going to go from the switch up to its sub interface on .05, come out on the sub interface .10 for VLAN 10, and then go to the PC. So we'll test it. We'll ping the IP address of the PC on VLAN 10 from the PC on VLAN 5. We type ping 10.10.10.2. Okay. Now it may take a second for it to come up, and we may get 2 or 1 unsuccessful attempts. There we go. So when you see the replies go through, you know it worked. If you want 100%, just hit the up arrow on your keyboard, hit enter, and you can get that 100%. Okay. Now, obviously, we don't have to go on the PC on VLAN 10 and try to ping VLAN 5 because, again, it's echo request and then echo reply. So it's going through in both directions. Now we want to see if the PC on VLAN 5 can ping the switch, right? Before we can remotely access into it, we want to make sure that we can ping it. If we can't ping it, we won't be able to remotely access it unless there's an access list preventing ping. So we'll ping the switch. We'll type ping 10.10.100.2. And again, we may have to wait. Got to be patient. Sometimes it times out. There it goes. It comes up 50%. So if we hit the up arrow again and hit enter, we'll get 100%. Great. So we got full connectivity, right? That's interface. That's VLAN, inter VLAN routing in a nutshell, right? In order to have inter VLAN routing, you have to create sub interfaces on a router. Another name for this is called router on a stick, right? So you got a single router. You have one gateway, but you have 3 sub interfaces for 3 VLANs. You could assign additional ports on the switch to other VLANs. So if you had another PC, and you connected it to port 4, you could connect port 4 to VLAN 5, right? And then give that PC an address in this subnet, maybe 5.3. Then you would have 2 PCs in VLAN 5. Okay. Now, the last thing we want to do is verify that we can securely and remotely access the switch, right? So remember, we're on the PC now, right? So to do that, we type the command SSH space -L followed by the host name, and I believe it was John, or your first name. Hit the space bar followed by the IP address of that switch, which was 100.2. Hit enter, and notice you're prompted for a password, and it should be ABC. Hit enter, and you're in the switch. Now, if you type enable, you're going to have to type Cisco to log in. Now you're logged into the switch remotely from the PC. So that completes that portion of the lab. Okay. I'm going to minimize this window. And then what we're going to do is this serial cable, right? We have a serial connection. Serial cables are used in wide area networking. A serial cable kind of looks like this, right? One male end connects to the serial port on one router, and the other male end connects to another serial port on a router. Now, normally these connections are used between a organization's edge router to the ISP router, and normally the ISP provides the timing signal. The timing signal doesn't affect bandwidth. It just affects how many, you send bits in chunks, right? And so it just specifies how many chunks you're going to send at a time. And so, if you send 56,000, you have a start bit and you have a stop bit, and in the middle, you got 56,000 bits. That just represents the size of the packets. Doesn't represent how fast they go over. The bandwidth determines how fast or how often you could send those packets over that link. So in this case, one end has to provide the timing signal. And so the building A router will provide the timing signal to building B over this serial connection. Now, what we're going to do is we're going to go on this router and we're going to configure the serial connection on using this subnet. Okay, 172.16.0.0/30. What the /30 means is only 2 available IP addresses in this subnet, which is what we want because this is a point-to-point link. There's only a possibility of 2 IP addresses in this subnet, one here and one there, right? And so the /30 means in that network mask, which is 32 bits long, the first 30 bits represent the network portion of the address. And so if 172.16.0.0 is the network address, .3 is the broadcast address, and the only remaining available IP addresses would be 1 and 2. So we'll configure the serial connections on the routers on building A, building B, test connectivity, and then from there we'll summarize it with creating our dynamic routing EIGRP routing protocol. So we click on the building A router, we type the command config T, we switch to the serial interface, so we type INTS0/3/0, hit enter, key in the IP address, we'll type IP ADD 172.16.0.1, the 30/30 net mask is 255.255.255.252. And we'll hit enter. We got to specify the clock rate because you can see the little clock at this end. We type clock space rate. We'll type 56,000. You can give it a description. They're optional. And we can call it connection to building B. And then we turn it on with the no shutdown command. Now notice the link stays down. On a serial connection, you got to configure both ends correctly in the same subnet before the link comes up. So now I'm going to click on the building B router. So we're going to type no, first time we're accessing it. we're going to type enable and then config T. I'm spelling it out this time. And then we're going to go to that interface S0/3/0, enter, IP ADD 172.16.0.2. And the net mask 255.255.252. And then we do the no shutdown command. Turn it on. Now notice the interface comes up and you see green link lights. And we can actually test that. We could type end, hit enter twice. And from building B, we can ping the building A address on serial 030. We type ping 172.16.0.1. And we get 5 successful replies. Now notice the ICMP protocol for ping works differently on a Cisco router, right? On the Windows machines, right, you get 4 32-byte echo requests and echo replies. Well, this actually sends 5 100-byte echo requests, echo replies. And as you can see, the success rate was 100%. Okay, so what we're going to do is we're going to advertise networks and with dynamic routing. The first thing we're going to do on the building B router is we're going to create what's called a loopback address. And loopback addresses, they're normally done for testing purposes. Like it's just like a fictitious network we create on building B, and I don't have to make all those connections on packet tracer with a switch and a PC. I can just create a fictitious network on building B using a loopback interface and advertise it and show you how it works. Another reason for a loopback address is some routing protocols like OSPF use the loopback address or the IP address to determine which is the designated router. And I'll go into that in the last lab, because the way OSPF works is if you got 5 routers and they're all in the same OSPF area domain and they're sharing network information, one of them's the designated router. And the way it works is all 5 of them send their updates to the designated router, and designated router sends their updates out back to everybody else. It's like the boss, right? Okay, so let's configure our loopback interface. We'll type config T, and we'll type INTL, which stands for loopback. You can spell it out if you want, and then 0. I can give it any address. Now, this is a practice lab. This isn't a production network. I can give it a public IP address. And it's right for the purposes of this lab, it's not going to matter any. And just to show you, a network being advertised in EIGRP, if I give it an IP address, let's just call it 1.1.1.1 space 255.255.255.252 and hit enter. Okay. And that's all we have to do on the loopback. Okay. It's there. So now what we're going to do is we're going to use a dynamic routing protocol such as EIGRP. Now, EIGRP was a routing protocol developed by Cisco. It used to be proprietary. It would only work on Cisco routers. Some years ago, Cisco made it open source, and now Nortel, Juniper routers connected to Cisco routers can use EIGRP. A while back, if you had a Nortel router or Juniper router connected to a Cisco router, EIGRP wouldn't work because it's proprietary for Cisco only. So you would have to use something like OSPF in those cases. But now you can use EIGRP or OSPF. And I'll go more over dynamic routing in the next lab. There's 2 types. There's link state routing. And so we'll talk about link state routing more in detail in the next lab. So what we're going to do to set up dynamic routing, okay, we're going to go to global configuration mode. And we're going to type the command router. Well, I want to show you something first, okay? We're going to look at the router's routing table, and you'll see how the building B router cannot see the networks for VLANs 5, 100, or 10. So if we do the command do show IP route to look at the routing table, right? All you see is the directly connected networks to it, right? It has the 1.1.1.0 network directly connected to loopback 0, and it has the 172.16.30 network connected over the serial link. So it only knows about those two networks. So it's not going to be able to reach the PCs on VLAN 10 or the switch on VLAN 100 or the PC on VLAN 5 because it doesn't even know those networks exist. Okay, so we'll use the EIGRP so the routers can advertise their directly connected networks with one another. Okay, so from here, we'll type router EIGRP space 100. 100 represents the autonomous system number, and that 100 has to match on both ends. Okay, otherwise they won't be able to talk to one another. Then we'll hit enter, and notice how your prompt changes. It's real simple. After here, you advertise all your directly connected networks. And you may say, well, why do I have to advertise this if building A already knows about it as well? It's used to establish a router adjacency. Both building A and building B are going to have to advertise that 172.16 network in order for the neighbor adjacency for the EIGRP routers to be talking with one another. So the command to do that, you type the command network or net, specify the network address, which was 0.0, followed by the network mask. Real simple. And then the building B router is going to advertise that loopback router address. Remember that 1.1.1.1 we created? Well, we advertise network addresses, not IP addresses. Okay? And we're going to key in 255.255.255.252. So as you can see from above, that's the address we used when we created the loopback interface. Okay? And we're going to hit enter. Okay. Now, the only way building A is going to be able to see these networks being advertised to it, it has to configure EIGRP as well. Okay? So if I go to building A, okay, and I do the command do show IP route to look at the routing table, I don't see them, right? All I see is my VLANs. I see VLAN 5, I see VLAN 10, and I see VLAN 100, and I also see this directly connected serial link, right? I don't see the 1.1.1.0. Okay. I'm going to type exit, go back to global configuration mode, and we're going to type router EIGRP. Again, that 100 has to match. Okay. First thing we're going to do is advertise that directly connected link. Remember, I said it's used to establish the neighbor adjacency 172.16 0.0, 255, 255, 255.252. Now, as soon as we do that, you notice that the neighbor adjacency pops up here, right? The routers are now talking EIGRP to one another, and we just need to finish it by advertising our networks, okay? Well, I still need to advertise my VLANs. Now, here's the thing, right? I'm going to teach you a little bit about summarizing network addresses when doing dynamic routing protocols. Notice everything here begins with a 10, right? 10, 10, 10 for VLAN 5, VLAN 10, and VLAN 100, right? The first octet begins with 10. Okay, now I can simply advertise that address. I don't hit enter. Just let me explain first. I could do it this way. I could just advertise the first octet, because what that says is anything beginning with 10, just send it to me. I'm advertising it to you. So if you got a destination address of an IP beginning with 10, just send it to me, right? Here's the problem with that. What if in the future, right, because this is all one organization, XYZ, what if building B creates a 10 network sometime in the future? Then you're going to have what's called a routing conflict. You're going to argue over who has the 10 network. So what you have to do, you could type this in. What you I'm sorry. Let me type that again. Net 10.10.10.0. Oh, I have to specify the wildcard bits. Okay, so the wildcard bits are opposite of the network mask. So I would type 0.255.255.255 and hit enter. Okay, so basically the way the wildcard mask works, it's like SpongeBob SquarePants opposite days. All the 1 bits turned on, all the eight bits that have ones would be represented by 0 here, 0 here, 0 here, and 0 and 3 here, because everything adds up to 255. And I'll explain more when we do the subnetting, subnetting, how the wildcard bits work. It's just the opposite of the network mask. Okay, so if I pull up a Word document, a notepad, okay, I'll show you real quick. Let me see if I can increase the font real quick. Font. Let me just make this font real big for you. Okay, here's what 255, 255, 255 looks like in binary. Okay, the wildcard bits are just the opposite of that. Change all the zeros to ones and all the ones to zeros. Then when you add them all up, first octet is a 0, second octet's a 0, third octet's a 0. But when I add all these up, right, the 128, 64, 32, 16, 8, 4, 2, 1, I get 255. So it's just opposite of the network mask. Okay, but remember, to prevent those routing conflicts in the future, I don't want to summarize that. I want to advertise the full, complete network addresses. I want to advertise 10.10.5, 10.10.10, and 10.10.100 over to building B. And so I just do the no auto summary. Okay. Now, what I want to do is look at the routing table on building B, and let's see if I can see those networks advertised to me. So I click on the building B router. I want to look at my routing table again, so I'm going to do a show IP route. I hit the up arrow a few times. You could just type it in if you have to. Do space show space IP space route. Hit enter, and I can see, now this is building B router. I can see what's being advertised to me. VLAN 5, VLAN 10, and VLAN 100. So in the future, if I create like a 10.10.20 and advertise it to building A, there'll be no routing conflict. Okay. Now what I want to do is go to the building A router and see if I can see that 1.1.1.1 network. I go to building A. I'm going to hit the up arrow several times until I see do show IP route. And I could see that that network's been advertised to me. So what you have here is full convergence in EIGRP. So if the PC on VLAN 5 wants to ping 1.1.1.1.1, it's going to be successful because its traffic is going to go from here to the switch to its sub interface, a destination of address of 1.1.1.1. That's the IP destination address. The router is going to look that up in its routing table, see an entry. It's an EIGRP route coming from building B, and it's going to send it to building B. And of course, building B knows what to do with it because it's directly connected. Okay, so let's test that. Let's go to the PC on VLAN 5 and type ping 1.1.1.1, and you can see I get 4 echo replies. So you got to see kind of how dynamic routing works. And so again, you got secure shell access to the switch. That worked. We created the VLANs. You know that VLANs are only layer 2 because it takes a layer 3 router, sub-interfaces for inter-VLAN connectivity. We created trunking. Here's our trunk port. Again, sub-interfaces on the physical gateway connection. We created the serial interface, and we advertised routes with routers using the dynamic EIGRP routing protocol. Okay, so that takes care of that. And so when we pick up on our next lab, we'll deal a little bit with security and access lists on routers. Okay, you all take care.